Welcome everyone. I'm Nasim Karam from Department of Computer Science, Allama Iqbal Open University. In this program, we will explore some exciting and futuristic applications of information and communication technologies. This is unit number 9, that is Future Applications in ICT from the course code CS5305. Let's get started. ICT has evolved dramatically. What started as simple computing has grown into an ecosystem of smart devices, cloud systems, and high-speed networks. From smart assistants to automated systems, IT has played a crucial role in automating tasks that once took hours or even days to complete. What once required extensive human effort can now be accomplished with just a few clicks. In this unit, we will explore some of the most exciting upcoming trends and applications that are shaping the future of ICT, from cloud computing and AI to the next generation networks and beyond. Let's start. As we know that information technology is at the core of all digital progress, a major trend is the shift towards more intelligent, responsive, and human-centered user interface and user experiences. UI has evolved from simple text-based interface to graphical user interfaces and now to natural user interfaces that includes touch, voice, gesture, and even eye tracking input. Technologies like AR, VR, haptic feedback, and AI-driven personalization are enhancing how user interacts with systems. For example, modern smartphones use facial recognition, voice assistants like Siri or Google Assistant, and adaptive brightness based on ambient lighting, all of which reflect advanced user interface, user experience design. Another example is Tesla's car dashboard user interface, which adapts to user behavior, offers controls, and provides real-time feedback to improve driver experience. Pervasive computing is another concept in ICT. Pervasive computing means embedding computing in everyday life, making technology seamlessly integrated and constantly available. Examples include smart homes with voice-controlled assistants like Alexa, wearable fitness trackers, and smart kitchen appliances that automate cooking or grocery management. These systems use sensors, connectivity, and machine learning to respond intelligently to user needs, often without explicit commands. Pervasive computing aims to create an environment where devices proactively assist users, offering convenience, personalization, and automation. For instance, a smart thermostat that learns your routine and adjusts your room temperature automatically is a real-world example of pervasive computing in action. Our next concept is personal area networks. Personal area network is a short-range communication network that operates in the immediate vicinity of a person, usually within a range of few meters. It's designed to connect devices that are close to an individual, forming a sort of mini network around them. Now, what kind of technologies make this possible? Some common examples include Bluetooth, Zigbee, and even infrared, which you might remember from older remote controls or early mobile file transfers. But where do we actually see PANs in action? A great example is the smartwatches. When your smartwatch syncs with your phone to track your steps or notify you of a call, that's a PAN network. Similarly, fitness trackers, wireless headsets, or even glasses, smart glasses, all operate using PAN to communicate with your smartphones or other personal devices. So the key benefits of PAN include convenience, mobility, and energy efficiency. So PANs may be small in scale, but they play a huge role in making our daily digital lives more seamless and connected. Another concept is wireless sensor networks. Wireless sensor networks are made up of tiny, low-power devices called sensor nodes. These nodes are distributed across the environment to monitor physical or environmental conditions like temperature, pressure, humidity, or movement. The sensors collect data and transmit it wirelessly to a central system or base station for processing and analysis. Wireless sensor networks are critical in areas like agriculture, smart cities, healthcare, and in disaster management. An example is precision agriculture. Sensors placed throughout a field that can detect soil moisture levels. If part of a field are too dry, the system can automatically trigger irrigation only in those areas, saving water, improving efficiency. So, wireless sensor networks contribute significantly to automation, safety and efficiency in modern ICT applications. Next is a powerful and widely used technology, radio frequency identification or RFIDs. RFID is a technology that uses electromagnetic field to automatically identify and track objects through small devices known as RFID tags. These tags can be attached to almost anything: product, ID cards, vehicles or even animals. The RFID system is made up of three main components: the RFID tag, the RFID reader and the backend system. The RFID tag, which stores the data basically, the RFID reader is to scan the tag using radio waves, and the backend system where the collected data is stored and processed. Now, where do we see RFIDs in actual? Imagine you are at a clothing store in a shopping mall. You pick up a few shirts and jeans that you like. Now, each of these clothing items has a small RFID tag sewn into the price label. As you walk towards the fitting room, the RFID system automatically detects what items you are carrying. Without any scanning, a smart screen outside the fitting room shows the details of the clothes you have taken, including their sizes, their colors. Now, suppose you try on a shirt but want to check if it's available in a different size. Instead of asking a salesperson, you tap the screen and the system connected to the store's inventory via RFID instantly shows you whether the size you want is available and in which aisle it's located. Again, once you were ready to check out, you don't have to scan each item individually at the cashier. The RFID reader at the counter reads all the tags in your shopping bag at once, instantly generating the bill. This makes the process faster, more accurate and much more convenient, especially when the store is crowded. So, RFID also helps the store keep track of which items are selling well and when to restock, reducing human error in inventory management. So, with RFIDs, the entire shopping experience from trying clothes to checking out becomes smarter, quicker and smoother. Another important concept in ICT is the collaborative computing. It enables teams to work together using shared digital tools. Imagine you and your classmates are working on a group assignment using Google Docs. All of you can write, edit and comment at the same document at the same time, even from your homes. You can also see who made what changes and chat directly in the document to coordinate. This is a real-time example of collaborative computing, making teamwork easier and more effective. Okay, let's talk about another very transformative technology in ICT today, which is cloud computing. Cloud computing is the model that allows users to access computing resources like servers, storage, database, applications, and even more over the internet instead of owning or maintaining them physically. Think of it like instead of buying and setting up your own computer to store data or run applications, you simply connect to a powerful computer in the data center hosted by companies like Amazon Web Server and use it remotely. This model offers a major shift from traditional IT setups. Earlier, organizations had to build expensive infrastructures, buying physical servers, hiring maintenance staff, manage upgrades, and dealing with power or cooling issues. But with cloud computing, all of that is taken care of you by the cloud provider. You simply rent the services you need, whether it's for a few hours or for a few months, and only pay for what you use. This is called a pay-as-you-go model. Some of the notable cloud providers and their services are Amazon Web Servers, Microsoft Azure, Google Cloud Platform, and IBM Cloud, which provide services such as computing, storage, machine language, and many more. The basic benefits of cloud computing includes reduced infrastructure cost, capacity and scalability, refresh aging infrastructure, support new business opportunities and business continuity without having some physical infrastructure available, increased collaboration which can save money, data and time. Another important future trend in ICT is the use of grid computing. This allows us to use computing resources more efficiently and flexibly in our daily lives and in large organizations. The benefits include scalability, cost efficiency and accessibility. Now let's move towards next generation networks or NGNs, another key development in the future of ICT. NGN refers to a type of network infrastructure that allows the transmission of voice, data and multimedia over a single unified network, usually IP based. Unlike traditional networks that had separate systems for telephone calls, internets and television, NGN bring everything together. This means faster speeds, lower latency and support for a wide range of services from HD video streaming to real-time communication and smart IoT integration. Technologies like 5G, software-defined networks and network function virtualization are driving NGN developments. These technologies provide the foundation for smart cities, autonomous vehicles and immersive digital experience. The ICT for development means using ICT to promote social and economic development. Examples include e-learning, e-health and online government services. It helps reduce inequality by connecting underserved areas. Another very important concept is of artificial intelligence or AI. It is one of the most transformative technologies of our time. It aims to create intelligent machines that can learn from experience, reason through problems and perceive their environment much like humans do. AI is no longer a futuristic concept. It's already making a significant impact across various industries in healthcare, in finance, in transportation, from retail to education. For example, in education, AI offers adaptive learning platforms that customize content based on individual student needs. Imagine walking into a modern hospital where your medical history is analyzed in real time by an AI system, and based on your symptoms, it suggests possible diagnosis, recommend some tests, and even assist the doctor in creating a treatment plan tailored just for you. This is not science fiction, it's already happening. AI is not just changing how we work, it's reshaping how we live. ChatGPT is a powerful example of how artificial intelligence is transforming the way we communicate. It is a language model developed using AI, designed to understand and generate human-like text. At its core, ChatGPT using deep learning, specifically a model known as a transformer, to process and respond to natural language input. This allows it to generate coherent, context-aware and meaningful responses in the real time. Whether you are asking questions, writing an essay, drafting an email, or even just having a casual conversation, ChatGPT can assist in a way that feels natural and intelligent. It's widely used in education, customer services, content creation, coding assistance, and many more, making it one of the most accessible and impactful AI tool available today. The future of AI technology is safer roads, body enhancements, unlimited virtual assistants, increased safety, and new jobs and industries. So conclusively, we can say that ICT's future lies in smarter interfaces, pervasive environments, cloud systems, AI and inclusive developments. These innovations are transforming how we live, learn and work. We hope this overview helped you understand the exciting possibilities ICT hold for the future. Stay curious, keep exploring and continue building your knowledge as future technical leaders. Take very good care of yourself. Thank you for watching.